Hello everyone and welcome to the video solution of option 1 of the Unit 5 homework, Pyber. The ride-sharing bonanza continues. Seeing the success of notable players like Uber and Lyft, you've decided to join a fledgling ride-sharing company of your own. In your latest capacity, you'll be acting as Chief Data Strategist for the company. In this role, you'll be expected to offer data-backed guidance on new opportunities for marketing differentiation. You've since been given access to the company's complete records of rides. This contains information about every active driver and historic ride, including details like city, driver count, individual fares, and city type. The first objective is to build a bubble plot that showcases the relationship between 4 key variables: average fare per city, total number of rides per city, total number of drivers per city, and city type: urban, suburban, or rural. In addition, you will be expected to produce the following 3 pie charts: percentage of total fares by city, percentage of total rides by city type, and percentage of total drivers. Some final considerations are that you must use the Pandas library in Jupyter Notebook. You must use Matplotlib, and Seaborn is not necessary, but it helps in making our graphs look a little nicer. And the plots should be labeled properly, such as titles and legends and axes labels. And remember, when making our plots, we want to consider aesthetics. We want to stick to the Pyber color scheme: gold for rural, light sky blue for suburban, and light coral for urban, in producing the plot and the pie charts. When we make our bubble plots, we want to experiment with things like alpha, edge color, and line width. Alpha here stands for opacity. And the same thing with the pie charts, but with shadow, start angle, and explosion. Let's go ahead and open up Jupyter Notebook. As you can see, I have a folder called Analysis, which will store our pictures that we save of the plots, and a folder called Raw Data that has our city data and ride data. I'm going to go ahead and open up a new IPython notebook. First thing I'm going to do is load in our dependencies. So we have Pandas, NumPy, Matplotlib, and Seaborn. Remember, we import these libraries as a shortened version to make our code easier to type later and a lot easier to read, because typing in matplotlib.pyplot every time we want to make a graph or adjust the graph is going to get pretty cumbersome, so we import it as plot. Next up, I'm going to load the CSV files and display the first 5 rows of each of them. We have our city data and our ride data. Remember, we want to specify the file path, which is go into the raw data folder and then pick the correct file. We have our columns for city data: city, driver count, and type, and our columns for ride data: city, date, fare, and ride ID. One thing we want to notice is that the common column between the 2 data frames is the city column, because up next we're going to merge them into a single data frame. So here we have our new data frame called city ride data. We're using pd.merge to merge the ride data, the city data, making the ride data the main one since we're merging left, and we're merging on the city column from each of the data frames. And as you can see, this now has 2 more columns: driver count and type. So now we're going to get started with the bubble plot of ride sharing data. The first thing I'm going to do is I'm going to create 3 new data frames that are filled with urban cities, suburban cities, and rural cities only. Okay, so here we're just taking the rows where type equals urban, suburban, and rural for our urban cities, suburban cities, and rural cities respectively. Next up, I'm going to get the urban ride count, the urban average fare, and the urban driver count. Here we're using group bys to count our rides. We use a group by because there are going to be multiple rides in one city, and when we combined the city data to the urban data, the city data to the ride data, we have multiple cities at the same time but different rides. So what we do is we group by the city and we count how many from each city, and then that is stored into urban ride count, and that is a list. Well, it's not technically a list, but it's kind of like a small data frame. Why don't we go ahead and display it to see what is there? Okay, so as you can see, there's a sort of index and values associated with those cities. So you had Carroll Fort, Davidtown, Davistown, and all of these have numbers associated with them, and that is the number of rides with this that have happened in that city. Now we do a similar thing for average fare, but this time we use mean and we look at the fare column, because it will take the average of this column right here, but that's not the number we want. let's go ahead and take a look at average fare as well. Okay, so same order, alphabetical, but this time you have your numbers, and this is the average fare for each city. Okay, and last but not least, we do the same thing for driver count. Now, this one is a little tougher because we don't want to just count how many drivers using our city ride data, because as I mentioned before, it's going to be the same driver count here associated with this Sarahberry as any Sarahberry that shows up later, because it's just taking this number and adding it since we merged on city, and so it has to have a value for each row. So what's going to happen is if we just counted, if let's say there are 2 Sarahberries, right? So 92, that's going to say 92 drivers for Sarahberry, but that's wrong. There's only 46. So what we do is we group by the city, and then we take the mean. It'll sum up the number of drivers, how many ever times that city shows up, and divides it by the number of times the city shows up. So we have it just the once. So it's the proper count for driver's count, and let's take a look. One way we can check that this is actually 21 is we can look at our city data where city is equal to this, let's say the first one, and if it comes up as 21, then we know that we have the right values. So let's quickly do that check. And we have our city in driver count at 21. So that means we're correct. Next up, I'm going to do the same calculations, but for the suburban and rural values. And these are going to be the same calculations as we did for the urban values. And finally, I'm now going to build the scatter plot for each of the city types. So what we'll do is we have to have a plot.scatter for each of the city types, and then we'll adjust them as need be. Here we have our 3 scatter plots with our X position as the ride count, the Y position as the average fare, and then driver count as the size. We times it by 10 to be able to actually see the bubbles. The colors are coral, sky blue, gold for urban, suburban, and rural respectively to keep with the Pyber color scheme. The edge color is the line around the bubble, which will be black, and we just want it to be 1 pixel, so we're not going to really do much more than that. The marker equals O allows us to make sure that it is a circle. The alpha here is for opacity, so it's 0.8, so it's not completely opaque. So if there are any bubbles hiding behind, any of the bigger bubbles, we'll be able to see them. And our labels are urban, suburban, and rural, respectively, for our city types. So before we go ahead, I'm just going to quickly display the plot so we can see what it currently looks like. Okay, so here we have it. We have one outlier all the way to the side, which doesn't super affect our data, so we don't really want to show it because we have this really, really big gap right here. So next up, I'm going to incorporate the other graph properties such as titles and labels. And remember, when you make any adjustments to your plot, you want to do them all before your plot.show so that they actually change. So here I've just added in a title, the x-axis label and the y-axis label. And here this x limits what part of the axis is displayed. So it's going to go from 0 to 40, and it's going to cut out this outlier. And I've just made a grid to make it look a little more appealing. So remember, as you work through this exercise, you want to continuously display your plot to make sure that what you're coding is actually what you want to show up. So I'm going to go ahead and run this again. And there we have it. We have a grid, and it goes from 0 to 40, and we have our urban, suburban, and rural rides. And as you can see, the bubbles do change size, and that bubble right there, you can see it, one hidden right there, is why we have the opacity at 0.8. Next up, I'm going to create a legend. And once again, this is going to be before the plot.show. So here we're creating the legend. We're just using plot.legend. We've done a font size of small, and the mode is expanded so it's not collapsed immediately. We just want 1 point for each of our labels, and we want a title of city types to signify that that is what the legend is about. The location is best, so if we keep it as best and any of the data changes, the legend will automatically move to the best position possible that doesn't cover any data. And we have some label spacing at 0.5, and those last 3 lines right there with the legend handles that signifies the size of the bubble in the legend itself. I'm also going to incorporate a text label regarding the circle sizes and save the figure before I run this again. Here we're just doing plot.text, and these are the positions. So 42 would probably be around here, and 35 is about right there. So we should have our note starting right here. And it just says note, circle size correlates with driver count per city. And so the \n allows us to go into the next line. And then last but not least, we have the save figure option. So we save the figure and we save it into the folder analysis and we name it fig1.png. One thing you want to make sure is that this folder actually exists before you run this code. Otherwise, it's not going to work. Let's go ahead and run it. Okay, and here we go. So we have our city types, urban, suburban, and rural. And as you can see, the correct colors are corresponding. And we have our note, circle size correlates with driver count per city. Let's take a look at our analysis folder, which has our figure 1, which has our Pyber ride-sharing data. Next up, we're going to create a pie chart that shows the total fares by city type. The first thing I'm going to do is calculate the type percents. First, let's take a look at this part. What we're doing here is we're grouping by the type of city. So all urban will be together, suburban will be together, and rural will be together. Then we're taking the sum. I forgot the parentheses. We're taking the sum, and we're looking at the fare portion so that it sums up all of the fares generated by urban cities. And then we're dividing by the total fare generated by all of the cities combined, timesing it by 100 to get a percentage. And types percents will hold all three. So why don't we take a quick look at types percents to see what we have. So here we have rural, about 6.5%, suburban, 31.4%, and urban, about 62%. Next, I'm going to build the pie chart. And this time, I'm just going to go through and do all of the titles beforehand. Okay, so here we have our types percents, and that includes all of these percentages right here. We have our labels, rural, suburban, and urban, and remember they want to be in the same order as our types percents, which is rural, suburban, and urban. Our corresponding Pyber color scheme, and this bit of code right here adds labels to the pie graph and it formats them. We want the number to the first decimal place and then a percent sign at the end. So we have a shadow equals true, and our plot title and our save figure to analysis figure 2. So let's run it and see what shows up. Okay, so we have our shadow right there, and if you remember, we want to explore with things like start angle and explosion as well. So what explosion does is it separates one of the pieces or more from the rest of them, and start angle tilts the pie chart a little. So let's go ahead and add some explosion and a start angle. So we don't want too much explosion. We've just picked one of them to explode, the point 1, which corresponds with the order from before. So urban is going to explode away from the others a little, and we've changed the start angle to 150. Let's go ahead and run it. And you want to make sure to remember that everything is spelled correctly. Okay, there you go. So we have our urban, our rural, and our suburban. We're going to do something very, very similar, except now we're going to do total rides by city type. This is very similar to how we calculated the percentages from before, except this time we're going to count them because we want the number of rides, not an average. And we're going to build a pie chart in a very similar way. So I'm keeping all of the edits that we did last time, just changing our values here to ride percent, our title, and the save figure, because otherwise it's going to get overwritten. Let's go ahead and run it. Okay, there we go. We have percent of total rides by city type, and once again, urban beats out the other two by a whole lot. Last but not least, we want to do total drivers by city type. Okay, the one big difference here is we're not using city ride data. We're using just our city data frame from the initial CSV file, and we're grouping by type. So urban, suburban, rural, and then we're summing the driver count and then dividing by the total number of drivers available. Once again, we keep the same aesthetic edits here, and our driver percents is what we just calculated. Let's go ahead and run it. Okay, and there we have our percent of total drivers by city type, and this time urban really beats out suburban and rural at 77.8%. Okay, let's take a look at our analysis folder and make sure we have our four figures as we want them. So figure 1 we already checked. Let's take a look at figure 2, percent of total fares by city type. Figure 3, percent of total rides by city type. And figure 4, percent of total drivers by city type. And that is the video solution to Pyber.